Well, welcome to Crossvale's webinar series about OpenShift. Today we'll be examining after the install and what you didn't know you need to know. I am Todd Millard. I'm the Chief Growth Officer at Crossvale. And with me today is Brett Kugler, our OpenShift Principal Architect. Today's event is scheduled for 45 minutes. And if you're really serious about OpenShift, we trust that it will be well spent time. There's a few housekeeping issues that I need to make sure I address with you. Everybody's mic is turned off. We do have a Q&A button at the bottom of the screen. We'll address your questions at our Q&A time at the end. If we're unable to get to your question, we will respond after the webinar with a response for you. So our agenda today. First, we will focus on a short introduction about Crossvale, so you know who we are. Then we'll jump into the OpenShift 4 overview, and we'll show you a demo of a deployment. Then we'll show you things that can go wrong. We're going to show you an example of how it can go way wrong pretty quick. And then finally, we'll address how to prevent these types of issues from happening. And then we'll have some time for a question and answer. So please, send us some questions that you have as we come through. So a little bit about who Crossvale is. We're an Apex partner for Red Hat. And so this year we've won the Leading Edge Award, and in prior years we were the Application Platform Partner of the Year. So we know this OpenShift stuff very well, and we know Red Hat very well. Crossvale's been helping clients like you guys for 20 years, getting more out of your enterprise application platforms. We focus on everything from day zero, which is build and enablement of Red Hat platforms, to day one in the development stage, DevOps, integration, cloud native application development, and then finally day two, operations and maintenance. We think we have the only complete OpenShift operational managed service. So don't settle for just fully managed. Go with Crossvale for fully managed. We are a preferred Red Hat services partner, and companies like Cinex and Dell and IBM and actually Red Hat Professional Services uses our team members to be able to deliver on their platforms. So that leads us to our operational OpenShift webinar today. And so what is OpenShift? Most of you attending, I'm sure, have a pretty good idea of what it is. But the common reasons most enterprises select OpenShift is trust is one of the biggest ones, because Red Hat is the best. Red Hat brings Kubernetes in a way that they have a world-class platform that gives you enterprise trust when you're running your critical workloads. And number two, cloud-like experience. This is where you get to take control of your cloud experience anywhere you run it, whether it's on-prem or in the cloud. And your users still get to have that cloud-like experience, and you still get to stay in control. And then business agility. When you empower your devs to solve problems quicker, it allows your business ideas to become business revenue much faster than ever before. So without further delay, I'm going to introduce Brett Kugler, our principal architect at Crossvale, to take us down the path of OpenShift 4. Brett, over to you.
Hey, thanks, Todd. And just wanted to say welcome for everyone watching. Really appreciate you coming in and spending a few minutes with us to kind of learn more about OpenShift, and especially OpenShift 4. So let's get right into it. So we're really focused on OpenShift 4 today, and really ongoing. It is the new next generation of the OpenShift platform. And there are a lot of really exciting new features that are being added constantly as the platform matures. Things like the operators, which make the whole operations management aspect of OpenShift much more convenient. We'll focus more on those later on in the discussion. On the development side as well, we have things like serverless and service mesh. We'll talk about a little bit as well. There's lots of exciting things coming along, and there's some great ideas out there that are starting to be incorporated into the platform. Things like everything from the automated installer to automated patching, or ease of cloud patching and those types of things. And also introspection into the clusters themselves with the kind of combined might between the logging aggregation that you get with the ELK stack or the EFK stack and the monitoring and the metrics and the alerting you get out of Prometheus and Grafana, which now comes deployed automatically in the cluster. This is no longer an add-on that you have to worry about at install time. It's built in. So all of these toolings are really built around helping you manage your cluster easier or more easily. So operators, what are they? We're actually going to do another webinar that focuses in depth on operators, but just for kind of a reference here, they're small pieces of code whose job is to manage and maintain certain aspects of the platform. So we mentioned the Prometheus Grafana earlier. That is managed with the cluster monitoring operator. And that operator's job is to install and keep in config, in a constant config state, the monitoring stack, right? And if new nodes come online, new namespaces come online, all of those things get automatically added to the monitoring stack through the operator. So it really helps us automate a lot of the processes that used to be manual on OpenShift in like the OpenShift 3 days. As mentioned, on the developer side, you know, some exciting new features around the service mesh and integrations with your microservices architecture to give you a really good look at performance, consumption, triage and problems, network routing between your services. All of those types of things are now being enabled through the service mesh. And then taking that one step further with Knative and allowing serverless runtimes on the OpenShift platform. And you know, this is really a feature that comes out of the public cloud. And one of the issues with serverless in the public cloud is the fact that it's gated pretty heavily in execution time and resource consumption. So having this feature available on your hybrid cloud with OpenShift really enables you to run serverless the way you want to, and not necessarily the way the public cloud provider might want you to run serverless. When we talk about OpenShift 4, the overarching idea here is that the operating system and the platform itself are tied at the hip now, right? In OpenShift 3, and even still in 4, there is an option to segregate those two. You can still run the operating system separate from the cluster. However, that increases your burden on management and operations because now you have two separate entities that have different ways of controlling and managing. So OpenShift 4 is coupled between CoreOS and the OpenShift platform itself to form what you might think of as almost like an appliance, where these things come together, they're managed the same, they're versioned in lockstep, they're updated the same way through the same process. And this makes the management of your entire cluster more simpler. All right, so let's look at kind of the install process and what it really takes to install OpenShift today on OpenShift 4. So we mentioned the automated installer, and we're going to see here that the install is very simple at its basic form, right? So the OpenShift installer is just a binary. You download it and you run it, right? We ask it to create a cluster. We tell it where to store all the installation artifacts. And then it's going to come back and it's going to ask us a bunch of questions. It wants an SSH key for accessing the nodes. We're deploying to AWS, so we got to tell it that platform. And we also have to tell it what region we want to deploy into. Then we do some DNS magic. We got to give it a base domain, and then we have to give it a cluster name. Those two things will be concatenated to be our actual DNS route into the cluster. Then we go to cloud.redhat.com and we request a pull secret for our OpenStack environment. I'm sorry, our OpenShift environment. And And that is what ties our subscriptions and our telemetry and all of that into the cloud portal that Red Hat is providing. And there's all sorts of nice, neat new ideas that Red Hat is implementing in their cloud portal. So if you have a Red Hat account, I suggest you go check that out, cloud.redhat.com. So now we're running the installer. It's creating all the AWS infrastructure for us, spinning up all the nodes, creating the networking and all of that. And then the Bootstrap node comes up and starts to provision its API layer and all of that. And once that's ready, the installer will proceed to actually install all of the software artifacts for OpenShift onto the platform. Now this is condensed. It takes about 35 minutes to go end to end. And obviously we don't want to sit here and look at that. So we've kind of sped this up a little bit. But we've finished with the bootstrapping. Now we're actually installing OpenShift. And all of these operators I was talking about are now going to town and doing the things that they do to bring the cluster up and alive. And there you go. We have it. So let's pop into the console real quick and take a quick look at what it looks like. And if you're used to OpenShift 3, this is going to look a little foreign. They've reworked the UI a little bit. And you know, it does take a little bit of getting used to, but the organization it's much simpler. Now, this is an interesting example. As a base deployment, right, we go in with self-signed certificates. Well, that's not necessarily ideal in a production environment or even in your standard environment. So this is a post-deploy operational task that you know, you have to manage. You have to put your certificates on your cluster, and you have to get all of that kind of set up for you. So if I can type the right password, there we go. We're going to log in here. And so, yeah, we're not going to spend a whole lot of time looking at the GUI here, but this is basically kind of the new look. But let's go look at the monitoring piece, right? So this is how monitoring is now integrated into the dashboard itself. So all of that Prometheus data that we're grabbing, we can now filter through directly from the OpenShift dashboard, and we can see our memory consumption, our CPU consumption, our quotas, network bandwidth, et cetera, et cetera. So again, from an operational, I can't even say the word, for operators and managers of the cluster, this is great, right? No more fumbling around on the CLI. You've got a lot of data here for yourself to visualize and alert even, right? So if something spikes, if it hits a threshold, you can set up alerting to visit, you know, what that problem might be and go address it. So I mentioned earlier all the operators. This is a brand new cluster, and there's tons of projects on here. That's because all of these operators now are built into the platform, and they all have to live in their own namespaces. So there's a lot of operational stuff underneath the hood that's happening immediately. All right, so we've installed a cluster. That's awesome. And guess what? That's all we've done. And to be honest, in the many installations that we've done with OpenShift 4, we've gone through this exact process exactly 0 times. So what this was is a pure, what they call infrastructure provided install. Maybe I got that wrong. Anyway, backwards. The point here is that the installer took care of everything for us, right? Which is great, but it doesn't give us control, and it's not particularly realistic when we're in an enterprise and we have to configure certain, you know, outlying issues, things like, you know, different DNS access, different networking types, different node counts, and all of that. So, you know, there's a lot of customization that goes in, and while the OpenShift installer plays a crucial part in all of that, it does need some customization, right? So we've gotten there, we've deployed our stack, right? And what do we do now? Well, let's just say we're happy. Okay, we're fine where we're at. Nothing, you know, we're all this other day 2 stuff. We'll worry about this later. But the devs are clamoring. So let's let the devs have access to their cluster, right? So what happens here is going to be an example of if you don't operationalize your cluster properly, you can get into trouble pretty quickly. So on the right, we've got kind of the overview of the cluster, and we're going to create a project cleverly called Chaos Devs. And the devs are going to go out and they're going to create an Apache instance so that they can run some web traffic, right? So this is all the typical process. We're gonna create a new app, and it's going to go through its build, deploy, and run phase. And really the intent here is, the devs are thinking, okay, well, one Apache instance is okay, but I really need more. I'm going to serve a lot of traffic. So once we see this start to come up and run after deploy, the devs are going to do something very interesting. They're going to say, all right, I'm going to take this deployment config and I'm going to scale it up. I want more Apache instances. How many more do I want? Well, let's go with 1,000. I think that sounds great, right? And so what happens? Well, OpenShift says, okay, I'll give you 1,000 nodes or pods of Apache. Sure, why not, right? This is great. And so over here on the left, you see that it's starting to spin up all these different pods. And if we check on the right, you'll see that we're still getting responses from the Apache instance. If we get this in here, right? Just a second. There we go. So we're getting, 200s from the endpoint. And so everything still seems to be fine, right? So what are we worried about? Well, what we're seeing over here on the left is that nothing is really up and running yet. All of these pods are still being created. And as soon as the majority of them start running, not even a majority of them, but enough of them, we're going to start seeing our cluster have problems. So if we watch the nodes here, right now, all of our workers are still in ready state. But as more and more of these pods come online, they'll start individually getting knocked out. And what's going to happen is eventually we're going to use up all the resources on our cluster, and it will become unresponsive. And that's kind of a pretty bad state to be in. So in just a second, as these pods continue to spin up, there we go. We start seeing our workers go to not ready status. And this is, again, it's being marked by the control nodes saying, hey, I can no longer talk to anything on these worker nodes because they have exhausted their resources, they have become unresponsive, so they're marked not ready. And that's pretty much it. I mean, if we try to hit the endpoint again, try to hit that service, now we're getting 503s, right? There's an internal problem, and we know exactly what that is. We've eaten up all of the resources. All right, so what really happened? Well, OpenShift, by nature, does a best effort to do whatever you ask it to do, including allowing you to basically DDoS your cluster by overloading it with consumptive resources, right? So all good OpenShift operators should go, well, of course, this is easy. We know quotas, limits. We need to gate the devs so that we don't allow them to do this type of thing, right? Well, that's great, but again, that's a maintenance step. That's something that you have to do post-deployment, right? And so this is something that we focus on a lot when we deploy OpenShift clusters for clients. We make sure as a post-deployment operation, we're setting up all of these resources and quotas and all of that. So if we go ahead and do that for our chaos devs here, right? I'm just gonna run another short little demo following the same process, but we're gonna do one small change. And over here on the left, after creating our new namespace, we're gonna actually give it this label. I'm gonna call this label small. And I'll explain what that does here in a second. But outside of that, we're not really doing anything else. But we do have this new resource quota. that we've built, right? So we'll show you an example of what that looks like. And I'll show you it again here in a minute on the next slide after the demonstration when we kind of talk about what's going on here. But you can see that we've now, we have this resource quota, and through the magic of this labeling and an operator, we've actually applied it to this namespace. So now we're going to run our example again. We're spinning up the Apache instance. After it builds and deploys and runs, then we will, again, try the service, watch it respond successfully, scale it, and see what happens. That's kind of the mystery here. And I think, the key takeaway here again is, as we kind of look at what's going on, we get to see the developer view and the Apache instance there. But what's going on here behind the scenes is that we now have an operator that is helping us apply these quotas to our namespaces, right? So when the devs come in here and say, okay, I'm going to create 1,000 replicas of Apache, OpenShift still says, well, okay, but what's it doing over there on the left? It's now bounding the deployment to the resource quota of 10 pods that we've assigned to this namespace, right? So regardless of what the devs request, they're not ever going to get more than 10 pods running at a time. And you can see that we don't have a service interruption. And this is a pretty simple use case, a pretty simple example, but it does highlight the power of the operator and the ease of management now that you can gain from leveraging these tools, right? So this is an example of the namespace config operator, right? This comes from the Red Hat community of practice, and it has this CRD that describes the kind of t-shirt sizing, right, if you will. You notice we labeled our namespace with a small, right? You'll see that match label here in the selector, right, for this CRD. And then you see that this resource quota is what gets applied when it matches that label. So this operator goes through and it monitors all the namespaces and it says, if I find a label that matches, I'm going to automatically assign these quotas. So instead of having to do all that manually, now all you have to do is label your namespace. And that becomes much easier to do in an automated fashion as well. All right, so small example. There are hundreds of more of these types of kind of maintenance and operational issues that, that a full active production cluster needs, right? And these are just some examples of what you really are challenged with. Well, how do you know how your cluster is operating? How is it running? And that's really where the Prometheus and Grafana stack comes in. And out of the box, right, Grafana is pretty well configured to give you kind of a basic look at what's going on in your cluster, right? There's a bunch of different views. You get nice graphs and all of that. But what if you can take that a step further, right? The operator is keeping the instance in lockstep so that you can't customize it, you can't get different views. But what if you could? What if you could go out and say, hey, I want specialized alerting, I want specialized graphs, I want to look at the cluster in different ways, the way I want to do it, right? And this is really kind of one of those niche areas where you have to have some expertise in understanding what's going on under the hood with the operator before you can start introducing new dashboards and new actions into the monitoring stack. But having said that, I mean, Prometheus and Grafana is really kind of the place where you want to start with your monitoring efforts, right? This gives the operations team the ability to have deep insights into what's going on in the cluster. So the operators are happy, or maybe your service provider is happy because it's now easier to manage the cluster. With that, Todd, I'm going to hand it back over to you.
Thank you, Brett. Appreciate all that great information. So that brings us back to how Crossvale helps solve these problems for our clients. So Crossvale has an OpenShift operational managed service, and one of our key differentiators on this is it's about you staying in control and us managing your clusters in your environments, and whether that's in the cloud or in your data center, whether you're running it on bare metal or OpenStack, a lot of different ways. We come in and we work with you in your governance models, and we bring to the table some proactive maintenance and some best practices that we've done with lots of customers that we're managing to help you get what you need, but to provide you with that trust that your critical workloads are going to keep moving the way you need them to. And so when we take a look at the benefits of the Crossvale OpenShift managed service, faster time to value. This is very important for people that are kind of new getting into OpenShift and they're newly moving critical workloads in there. Having a team like our team that comes in and handles the maintenance for you and also proactively goes in there and helps you build what you need to be able to understand what's going on in your environment, plus somebody that's going to be able to remediate issues. It gets you to be able to get to critical workloads faster by having a team that is experienced to help get that done for you. Reduce operational overhead. We can do it cheaper than you can hire your own resources. So we have a way to be able to get the right resources, keep them trained, and their entire job is all about OpenShift and being trained on OpenShift and new features, which for enterprises that are trying to drive their own business needs, sometimes this is hard because people have multiple jobs and they're trying to keep the lights on. That we're focused, this is 100% our job. Our team works around the clock, 24/7, 365. So you don't have to worry about getting a call at 2 a.m. on Saturday morning because some issue came up where there's an alert. You have a team there that's going to take care of that for you. Also, having a team take care of the platform means that you can focus on building and deploying innovative solutions so your developers are focused on that and not spending a lot of time with administrative tasks. And then we have a plan for every budget. So regardless of where you're at, whether you need 24/7, you only need 9 to 5, we can also customize different solutions around how we can deal with maintenance for you and slice and dice it to meet your budget. So next, this is the first in a series of 4 webinars about OpenShift 4. And so we've done that after the install. Our next webinar will be coming up in some weeks that will be about operators. And so there's a lot of cool things going on with operators. And this is, an area that many of our customers are asking us a lot of questions about on how they can capitalize on all these operators and what's the best way to implement them and use them. And there's so much around that. So we're going to be going into that. CI/CD, always very important. OpenShift helps tremendously with this, but there's, different ways that you can develop that. We have a very prescriptive approach that we've used in many different ways that have really helped our customers get up to speed on that much faster. So CI/CD will be the next one. And then service mesh. So now we're getting to the developers here and talking about how we can deal with, the Istio is the upstream version of this. And, it is a really cool new feature now that OpenShift has also. So we'll get into service mesh as well. So we're here, we know this stuff and we spend all our time focus on here. So now we're going to move to the Q&A. So let me take a look at questions that we have out here. Okay. We have a couple. We have a 3.11 and need to upgrade to 4.3 or 4.4. How much rework can we expect? Brett, can you kind of address that on 3.11 to upgrading to 4.x?
Yeah, absolutely, Todd. It's a great question, and obviously everybody who has a 3.x cluster is thinking about the migration path. And there's every cut is a little different, but ultimately what Red Hat has done is provide some significant tooling to help in that migration effort, right? I think the thing I stress most of the time is it's not an upgrade. There is no upgrade path. It is migration. You will have to create a new cluster. You will have to move your workloads from the old cluster. And like I said, there's tooling that's provided already. If you've kind of followed best principles along the lines of CI/CD, DevOps, then you have a lot of stuff already automated, and redeploying onto the new cluster might actually be fairly simple. The harder question is, how do you move your data? And with that, again, Red Hat has provided some means and methods for moving your persistent volumes from the 3.x cluster to 4.
Great. If we started using your managed service, who would be responsible to move my nodes to your cluster, and which cloud provider do you run your service on? This is a great question. And the interesting thing about this is we're not moving your nodes into the cloud. What we're doing is we're coming to you and we're managing your cluster wherever you have it at. Like, we have customers that are running in Azure and AWS and on-prem and multiple different data centers, and we manage all their clusters right where they're at. And we work with their teams in order to make sure that we're working within the right security guidelines, governance models. The communication plan is set up, working with how all that communication works for, resolution tickets that come to us, or if alerts are coming to us on how we're going to remediate those issues. We have plans already in place on how to deal with a lot of this stuff, but we also work with your team in order to make that something that is your solution, not just some way we dictate that you need to do it this way. And that's what our big differentiator is. So we don't have to move it. We manage it right where you have it. That's the two questions that I had out there. I don't see any other ones. So I want to thank you for attending. And there's going to be a survey that just takes a couple minutes. Please fill out the survey so we can understand what we've done good, if there's areas we can improve upon. Since we have more webinars coming out, we'd like to deliver the best content and the best version of the webinar to you. So thank you very much. You guys have a great day, and we'll see you on the next webinar.
Thank you.